The next position I'm discussing is called Falsificationism and Deductivism or Deductivism, and the names will become clearer in the course of the development. It was developed by Karl Popper, who was born in 1902, died in 1904, an Austrian philosopher, and in the 1930s he published in German the book Logik der Forschung from 1934. It was practically not received at that time. Popper was more or less unknown, and he became known then for other books, but later then this was published in English. Popper emigrated to New Zealand in 1937, took a position at the London School of Economics and Political Science in 1946. After the Second World, he came back, and then he became really very influential, especially in Britain, much less in the United States, but also in Germany and Switzerland. He became extremely influential in the social sciences. He was one of the most influential philosophers of science in the second half of the 20th century, together with Kuhn. They were the most influential ones in this time period. Now, falsificationism is a normative philosophy of science. That's very important. So Popper wants to say what is good science. He wants to evaluate science. He doesn't say, I describe how science actually works. That's, of course, like in normative economics. You say, well, this is also what people really do. But it's basically a normative philosophy of science in which norms for good scientific practice are articulated, right? And it's inspired by physics, or one should say Popper's understanding of physics, because Popper was not a physicist. He did study some physics, but he was not a physicist, so I leave it open how well that understanding of Popper's represents real physics or not. Okay? And because of that, and Popper is very explicit about that the ideal is physics, it was therefore, this philosophy was therefore attractive for all scientific fields that felt inferior to natural science. So all the social sciences, at least most people, think, oh, we are not that as good as physics, and our science status is problematic, and why can't we copy something from physics? And then these people turned then to Popper, because Popper promised, so to speak, I give you the fruits of physics and tell you how to transform your science, your field, into a respectable science similar to physics. Now, this is the basic aim of falsificationism. That's also very important. Develop a position that avoids the philosophical problem of induction. Popper started as an educator, but then he was quickly into a philosophy of science, and he saw how the philosophers discussed the problem of induction. And the problem of induction seems unsurmountable, right? This is a sort of consensus. You can't solve it. And then Popper said, oh, damn it, we've got to avoid that problem somehow. And then he said, I develop a position that avoids the philosophical problem of induction, right? That is independent, of course, that scientists don't care about the philosophical problem of induction, but that's not the point. Because he's a philosopher, he has to focus on the philosophical aspects, and therefore he wanted to avoid the philosophical problem of induction, namely no justification available for the generalizing step in induction, even in the functioning cases, all right? So, and here's the basic idea of falsificationism. This is the basic aim, and then he has an idea how to develop, how to put this aim into practice. He says, scientific hypotheses, model theories, and so on are not built up bottom-up from data, like inductivism. Right? Inductivism says, get some data, theory-free, and then cleverly generalize inductively, and then you get to the level of generalities, models, theories, and so on. So, because there is this inductive step, we have no justification for it, we've got to avoid that, and Popper avoids it by saying, no, it's the other way around. We start with the hypotheses, model theories, and so on, and test them deductively against data, top down. Why deductively? I explain in a minute. So that's the idea. So inductivism has a procedure of bottom up. You start with the data, they are secure, then you generalize, and Popper says that doesn't work, right? We have no justification. Therefore, reverse the process, start with the hypotheses, models, theories, and test them against data, right? And the testing procedure, we'll see, is deductive. Right? Now, there is a side effect to that that's very important. The side effect is this gives the theoretician much more freedom for hypothesis model theory building than inductivism. Because as an inductivist, you are really a slave of your data. The only step you are allowed to do is generalize from the data to the general level, right? You have no freedom there. Whereas if you have Popper's procedure, you have much more freedom for the theory construction, because you can construct, in a sense, anything with some restriction. I'll come to that. And then you say, okay, in basis of that, we got to test the construction and find out whether it's correct or whether it's in confrontation with the data. So you've got much more freedom. And this is one of the principal advantages of deductivism. In inductivism, you can never understand how science introduces highly theoretical constructs, because you do not get the constructs inductively from observational data. If you introduce certain things that don't exist in the observation, right, then you can't see how inductivism can ever reach them. So it opens up the universe, so to speak, of theoretical constructs, and in order not to be limitless there, you have to have constraints, and the constraint will be they have to be tested against empirical data. Right. So in order to establish deductive testing procedures, I'll show you why deductive later, they must be applicable, and they are not applicable to just anything. They are only applicable to what Popper then calls scientific hypotheses, models, theories. I will talk about hypotheses in short. And they must fulfill a specific condition in order to be testable. Not everything is testable by data, but only a specific subset of hypotheses. And Popper wants to delineate that subset, and that is done by the so-called demarcation criterion. It demarcates scientific hypothesis from non-scientific hypothesis. And the condition demarcates scientific hypotheses, especially from others like metaphysical, religious, or pseudoscientific ones. This is given the context in which Popper worked there in the 30s. This was the enemy. You know, the enemy was for philosophy of science was this metaphysical stuff, religious, pseudoscientific one, and the idea was we want to demarcate proper science from that unscientific or anti-scientific stuff. And now it's important that in this context, the demarcation criterion tells you what a scientific hypothesis is, but in a very special sense, namely only in the sense that it can be admitted to scientific testing procedures, and not in the sense that it is a true or accepted scientific hypothesis. It only tells you this is a hypothesis that can in principle be discussed in science. It doesn't say it will be accepted in science. It only says it can in principle be discussed in science, whereas the other things, metaphysical, religious, pseudoscientific, cannot even be discussed in science. So that's the demarcation. It's not a demarcation between what scientists say, this is a very good hypothesis. No, it's a demarcation between what scientists say, this is not science at all, and here is science, right? And the demarcation is between science and non-science, and there are crazy hypotheses, which could be scientific hypotheses, utterly wrong, but they are not metaphysical or not pseudoscientific, but they are on the side of the scientific hypotheses. I'll show you in a second an example for that. So the demarcation criterion says the following. A hypothesis is scientific in this sense, right? Only in this sense that it's possible to discuss it scientifically. It's scientific if and only if it's empirically falsifiable. And empirically falsifiable is now, you've got to be very careful because many people misunderstand that. It means that there are empirical circumstances imaginable such that the hypothesis is refuted. They must only be imaginable, right? So, for instance, there was a discussion in Nature, in this top journal in natural science, where scientists then said, okay, if I follow this, then the hypothesis, the Earth is approximately a sphere, is not scientific. Why not? Because you cannot falsify it. There are no data that show you that this is false, right? If all the data that we have show that the Earth is approximately a sphere. So these people then concluded, therefore, this hypothesis is, according to Popper, not falsifiable. You cannot falsify it. Yeah, there are no data that you can falsify. Therefore, it can't be scientific, right? That's a completely false understanding of what Popper meant. What Popper meant is there are empirical circumstances imaginable. You can imagine that you take a satellite and you look down to the Earth, and then it's a square. It's a pyramid, right? The form of that's imaginable. The question is not whether you do get these falsifying data, but the question is whether these falsifying data are in principle possible, imaginable, logically possible, right? And some scientists really, even in Nature, they misunderstood that completely, and then they said all this philosophy of science is all bullshit because they think the Earth is approximately a sphere, is not even a scientific hypothesis. I'll give you an example in a second, okay? All right, so this is very important. It must be empirical circumstances imaginable, not practically achievable, right? So according to this criterion, the hypothesis, the moon consists of green cheese, is a scientific hypothesis, right? This is this other understanding of scientific. I mean, no normal person would ever say that, would say bullshit, right? But according to this understanding, the moon consists of blue cheese, or green cheese, what did I say? Well, it doesn't matter, both are scientific, right? Because you can falsify it empirically, right? You go up there and look there, taste it, well, look at it, for cheese, you're gonna probably taste it, and then, no, it's not of green cheese, therefore it's falsified, right? So this is, according to Popper, a falsifiable hypothesis, therefore a scientific hypothesis. So you think, wait a minute, what sort of demarcation is that? So, a scientific hypothesis, that's another way of talking, is in principle empirically testable. You can test it by empirical data. An example that's not falsifiable is a very ancient, from ancient Greek philosophy, pre-Socratic as it's called philosophy, the universe is governed by love and hate. You may say, oh, that's an interesting hypothesis, that all the forces in the universe, it's love and hate, things approach each other and others hate each other and they approach and destroy each other and blah, 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 blah. And then you can take long stories and find this is wonderful, what a deep thinking that is, that must be really philosophical, to see that. And Popper says, bullshit. Because you cannot imagine anything imagine anything empirical that contradicts this hypothesis, because you can assume just everything under this hypothesis, right? So if you have things attracting, then you say, yeah, they love each other, sure. Or they go away from each other, then you may be reminded of Helene Fischer and her ex-boyfriend, or whatever, and love and hate, and then you have something with equilibrium, you have things that are in equilibrium, you say, sure, there's a balance between love and hate, sure. So you can never find anything where you can say, this damn hypothesis is just wrong, anything empirical. And this is what Popper has in mind, right? The same also with religious, pseudoscientific stuff. But this is the sort of thing where Popper said this is metaphysics, and this is not falsifiable in principle. There's nothing imaginable at the empirical level that can show that this is false. And this is the basic idea of falsification, and that's a very attractive idea, one has to say, that you say all in science we do, we articulate only thing that can in principle be empirically tested. If it's not testable in principle, then it's not science. This is the background of the discussion, you may or may not know of it, about string theory. String theory is a theory in high energy physics, elementary particle physics, and these people are 10 to the 15 are they away from empirical confirmation or testing, and therefore some people say this is not physics anymore, this is just nonsense, and other people say no, this is deep physics. So this is that discussion in a sense. Okay. This is what I said. Whatever happens empirically can be subsumed under this hypothesis. Thus, this hypothesis cannot be empirically refuted, and therefore it's not a scientific hypothesis. It's especially the refutation. So empirical data must be in principle imaginable that show that the hypothesis is false. This is what Popper wants. In other words, one can put it this way, scientific hypothesis must be empirically risky. Right? You may encounter empirical circumstances, which show you this is false. It is not consistent with the data. So for scientific hypotheses, there's always danger that they are shown to be false by confronting them with empirical evidence. They may be falsified. Now, this is that specific sense of falsified. Note that in English the word falsification has two meanings: showing to be false and also tampering, and changing it somehow. Whereas in German, and Popper wrote in German, there's only one sense of falsification. You would use a different German word if you tamper around with data and change it somehow and make big swindles or so. So shown to be false by empirical data. This is the idea. Science is an enterprise that produces hypotheses that can be, in principle, falsified, shown to be false by empirical data. All right. So this was the condition, the demarcation criterion, about hypotheses that can be discussed in science, right, and should be discussed in science. And now comes the next step, namely that Popper says, yes, these hypotheses that have the property of being falsifiable in principle, they are then tested, and the testing procedure is called deductive hypothesis testing. And this is, again, very obvious. You will see that immediately. The main tool for the empirical test of hypothesis is logical deduction. Right? This is the tool. You need, of course, the data, but the tool is to get from these hypotheses to the data is logical deduction. And what you do is simply, from a general hypothesis, specific sentences are deduced that can be tested by empirical data. You have a very general hypothesis, and then you deduce something from it, so something which is contained, plus additional premises perhaps, and then you deduce something, and then which you can test immediately, or more or less immediately. So I give you an example, a very topical example. This is the biggest physics event of the at least last 50 years or so that happened really. This is the testing of gravitational waves that were discovered in 2015 and were published in 2016. So it's an event that is absolutely breathtaking. So what happened there? So deduce from general relativity theory, that's the gravitational theory, deduce the gravitational wave patterns that certain cosmic events produce, e.g. the merging of two black holes. So two black holes, then general relativity tells you if two black holes, if they merge, they spiral and then they merge, they will send out a certain pattern of gravitational waves. That's the prediction of the gravitational theory. So what you do then as a theoretician, you say, okay, well, in fact, it's 250,000 such called templates that people have calculated, and they have a library of templates, all the possible, what they imagine for them, imaginable events that produce gravitational waves have been calculated on the basis of relativity theory. And then you observe gravitational wave patterns and compare them with the predictions of general relativity. And then you find a pattern that happened in September 2015, and that pattern matched wonderfully the pattern calculated of two black holes of, I think, 26 sun masses and 34 something, merging and then being one black hole and then sending off a burst of waves. And then, if the measurement differs significantly from the prediction, the hypothesis failed the test and is falsified. Otherwise, it survived the test. So in this particular case, general relativity could produce a wave pattern by saying an event of that sort will produce the following wave pattern. That wave pattern was measured, and then you say, okay, we tested general relativity, and it has been confirmed, it's not been falsified. All right. The first prediction was exactly 100 years before. It was in 1916 that Einstein predicted the existence of gravitational waves, and it took 100 years that people discovered them. So the idea then is in deductive hypothesis testing in falsificationism is that hypotheses are kept in science as long as they have not been falsified. All you can do with hypotheses is trying to falsify them. There's no positive procedure by saying, oh, I'm very happy about it. The only happiness is if a hypothesis failed to be falsified. Right? This is very important. This is the spirit here of falsificationism. So, according to Popper, science is the continual invention of falsifiable hypotheses and their critical empirical test. This is all about science in one sentence. This is what science is all about, right? Yeah. Theology is, of course, not a science for Popper. And it's certainly not a science in the sense of natural science. Whatever theology is, it's certainly not a natural science. Well, the common consensus seems to be that there is no direct empirical test of any sort. Bertrand Russell, a confessing atheist, who wrote a book, Why I'm Not a Christian, and he was asked then, hey Bertrand, what happens? Imagine you die, and then you go to heaven, and then God asks you, hey, why didn't you believe in me? And then Bertrand Russell said, because you didn't give us enough evidence. Right? So the sort of evidence that people who believe, who are believers, have a certain faith, the data they are using are just not intersubjective usually. Right? They are just, they describe them then as a sort of confrontation and talk with God and so on, but according to the standards that used in science, these data aren't good enough. And for Popper, of course, theology is a typical, not a science, is either a pseudoscience or religious belief. It's just a different kind of thing. Right? This is not the full story, and usually these philosophers of science are not specialists in theology, and if you talk to very sophisticated theologians, you're going to be very careful, right? Because they are not stupid. Well, people have given that up to some degree, so people try to have proofs for the existence of God, and there are very few people nowadays in theology or philosophical theology who still do that. So people have given that somehow up, and it's probably the wrong path if you want to defend religion as a cognitive enterprise. But that's misguided anyway, I think, but that's a different story. Okay, so this is now a very important lesson in Popper's philosophy. Science does not try to confirm hypotheses. Science is really a very negative, critical enterprise. It tries to disconfirm or falsify them. And this is very radical, that many people underestimate the radicality of Popper's position. It's thoroughly negative. It only says, invent something, and then we'll test it, and we aim at throwing it out by showing that it's false, by falsifying it. The spirit of science is thus fundamentally critical, right? Really fundamentally critical, and this is of course also very attractive. If you look at the self-image, now I'm talking psychology, if you look at the self-image of scientists, they are happy to say, yes, we are the most critical people in the world, we criticize everything, we are anti-dogmatic, and that sort of spirit is nicely articulated by Popper. Whether it's true is a completely different story. I'm just telling you the self-image, and that way that Popper depicted science was an image of science that many people in science could say, yes, that's me, yes, this is what I want to be anti-dogmatic and completely anti, and I test everything, nothing goes through, and I have no biases and so on. So this is the pathos of science. Science tries to be as unbiased and dogma-free as possible by testing all proposals as severely as possible. And there are many scientists say, yes, that's me, yes, this is what I'm trying all my life. All right, whether that's true is a different story, I told you. Okay, and I'll come back to it. Now, this position is also called critical rationalism. That's more in German, a little it's also used in English, critical rationalism. And the reason is rationalism stresses the rationality of scientific procedure and the opposition to empiricism in the sense of positivism. Right? So the positivistic position has also been called empiricist because you start with empirical data. And then the opposition to that, the term or the concept opposed to empiricism, is then rationalism. This goes also back to the discussions in the 16th to 18th century. So this is the reason. Therefore, it's called rationalism, because you may say, wait a minute, this is called rationalism, but it's purely empirical, right? All the tests have to be empirical. What does this has to do with rationalism? So these are the historical roots. Don't get confused by that. The main essence is everything in science has to be tested empirically. This is falsificationism, and all the activities are directed at critical tests of general hypotheses. Okay, that's the idea. This was as I said, very successful in the 60s, 70s, 80s, extremely successful, much discussed, also in economics. I'll come back to that, but first let us see some problems of falsificationism. Only one problem, one main problem. Now, the rule that science should never stop its attempts to critically test hypotheses leads to unintended and unpleasant results. This is very, as I said, it's very radical, and it's so radical that one gets a real problem with it, with that idea. I mean, it sounds at the first take, you may say, this is wonderful. Yes, that's how it should be, right? But you have consequences. Now, suppose you have a hypothesis that states a specific functional dependence of a variable y on a variable x. So x is a function, y is a function of x. This is your hypothesis. And now you say, okay, let's test empirically according to the Popperian maxims. Let's test that. So to give an example that's more familiar to you, in the notation you are aware of, so P is the price of X, and the quantity QD and the quantity supply. QS is quantity of X demanded and supplied. So the price is a function of demand and supply. And if you write that equation down, then you think, yes, this is a sort of, well, whatever, law or regularity or something in principle valid for economics. Now, the problem is, for Popperianism, I'm not saying in general, but for Popperianism especially, it's the following. That if you have an equation like that, x is a function of y, I'm going now back to this one because it's then simpler to discuss, does not only state that x depends on, y depends on x in a specific way, once you've written down the function, but it also states that it does not depend on additional independent variables u, v, w, etc. If you write down the equation, if you write down y is a function of x, you implicitly say it doesn't depend on any other variables. And this is problematic because the list of potentially influential variables is indefinite. It includes, to have just two examples, the haircut of the experimenter, the position of Venus, and whatever you want. How many chairs are in the next room, right? It may depend on it. So if you are a Popperian, you have to say, well, I don't know, it would be dogmatic to assume that the haircut of the experimenter doesn't play a role, so we have to test it, right? So you have to run the experiment with every conceivable haircut of the experimenter, with every conceivable number of chairs in the next room. If you say, but that doesn't play a role, then the Popperian says, no, that's dogmatic. How do you know? Have you tested it? No, you haven't. Okay. And there you see, you have infinitely many variables that could be influential on your variable y once you've stated y is a function of x. And if you're a Popperian, you must test that. You can't simply say, oh, that's implausible. Wait a minute, you're a scientist. You've got to empirically test whatever you claim. So it never ends. You know, your testing procedure for the simple thing, y is a function of x, does not end anywhere. Because you can always say, oh, now I have Venus. How about Jupiter? You know, Jupiter also changed. And the moons of Jupiter, they have very different constellations. So you've got to check all the possible constellations of the moons of Jupiter, and so on and so forth. And also whether the experimenter is just in love or just divorced, or whether he's gay, or whether he's heterosexual. It can all have an influence. You never know whether he wears glasses or not, where he comes from, whether he's from Taiwan, but now in mainland China, or whether he comes from Singapore and is now in Hong Kong, can all have a different influence. You don't know. You have to test it empirically. And you see immediately this is infinitely many things which you can't do. It's just not practical. It's just impossible, right? So it's impossible to stop testing. Absolutely impossible. But this is not allowed according to falsificationism. If you want to stay within science, you have to test. You must not say just dogmatic things. Everything you claim, you have to test. And you see immediately this imperative of testing is somehow self-destructive. You got to stop it somewhere because you can't do it, right? So you got to stop it somewhere, otherwise it collapses because it's self-destructive. Now, in economics, that sort of problem is visible. It's not solved, but it's visible in the ceteris paribus condition. There you simply say, look, we put all the other ceteris, you don't know which they are, but you just say, everything is constant, right? So I don't care about these variables. And I only look at this variable, and you just set it constant, and then the problem, well, hasn't disappeared really, but it's pushed away from you. So this is, I'm not discussing that at this point in detail, the ceteris paribus condition, but there you see the problem, right? That the economists are aware of that. You have one variable and it's dependent on another variable, and then you know there may be many other variables that are important, and just put them constant, and then we can discuss this specific dependency of y on x and not on the other things. Okay, so for instance, higher oil prices lead to less demand for oil. Ceteris paribus, of course, yes. If at the same time, something happens, then of course that doesn't hold. It only holds if everything stays constant. That's relevant for the case in point. All right. So this is one of the problems that falsificationism has. We will see later that the position of Thomas Kuhn, the paradigm theory, is one that tries to answer that impediment, that problem that falsificationism has, that it has no stopping procedure, right, for testing. And you have to have a stopping procedure. You can't be critical all the time against everything, because then you end up in nothing. There must be some sort of stop for testing, right? And that doesn't, falsificationism doesn't supply that, and I think it really cannot supply it. It really doesn't work. There is something deeply missing there, as attractive as it sounds with that criticism, but it doesn't seem to work. Okay, now let's see what economists did with Popperianism. And I give you here literature. These are the books and stuff that is in the initial literature list, and there are the concrete, if you want to read something, there are the pages where you can read something. So as I said, for these discussion application of these, it's the Fabi I found the most useful one. The other ones are more specific typically. Now, Popper's main methodological work, the Die Logik der Forschung from 1934, was not much received at the time. I said that already, but it was translated into English in 1959, and they're called The Logic of Scientific Discovery. And then it gained massive influence in many social sciences, including economics, especially in the 1960s and 1970s. And the main discussion of Popper in economics is between the 60s, 70s, and 1980s, as we see with the other positions as well. This is where the economics and general philosophy of science had most confrontations and discussions. But the important point is, and I'll come back to that, that before 59, Popper influenced economics in an indirect way, because Milton Friedman's essay of 1953 was influenced by Popper very strongly, because they had a personal meeting in 1947 at the Mont Pelerin Society, and I'll discuss that later. Mont Pelerin is here in Switzerland, and the liberal, the market liberal economists, Hayek and others, met there in 1947. And Popper and Milton Friedman had long discussions there, and only much later Friedman said in an interview that this influenced him very much. So this resolves the puzzle how Popper could be influential into mainstream English-speaking economics. This is one of the reasons, is this one. Friedman doesn't read German, but he had this discussion with Popper in English in 1947. Okay. Friedman's essay in turn influenced many economists, so Popper was present. Some people even say that Popper dominates the thinking in economics. Other economists disagree strongly. Anyway, Popper is an important direct and indirect influence in economics. All right. Now, Popper's philosophy of science seemed attractive to many economists because he promised the possibility of turning economics into a respectable science like physics. And you will see that then in Milton Friedman's essay in 1953, he quite clearly says it, that economics can be a discipline as respectable as physics. This is quite clear, and this is one of the reasons, of course, why Friedman turns to Popper, and he thought, there I can articulate a methodology for economics that transforms or continues with the best tradition in economics, turning it to a science as solid, intellectually respectable as physics is. On the other hand, it was fairly obvious that the idea of falsification did not fit economics very well. If you understand the radicality of Popper's proposal, and you look even in a very superficial way at economics, it somehow does not look the same as what Popper says. So for instance, if you look at the practice of economics, it did and does not present itself as a ruthless attempt to falsify economic theories, models, etc., and in the case of falsification, gives them up. It just doesn't look it. By the way, other sciences don't look it either. So if you look at people, it's much stronger. If you look at it, they try to confirm something. They build something up and not constantly trying to destroy something. So in economics, of course, people try to improve their model and so on. And it's very rare that in economics people say, no, this is really dead. It's been falsified. Forget it, right? So it looks rather that people then try to modify and so on and so forth. Even if a very superficial way of looking. If you ask the historians of economics, they also say similar things. Now, some key elements of economics even seem not to be falsifiable. That you say, what should happen? Imagine, empirical things happening such that you say, this is the end of that part of economics. For instance, expected utility theory. I mean, what could happen that you say, wow, this is expected utilities is dead, period. Right? It's very difficult because you've got so many things where you can fiddle around. And they appear to be immunized against falsification by ceteris paribus clauses. You could always then immunize, say, wait a minute, ceteris paribus, that's not my precondition. And then that looks that you can always, falsifying instances, you can always say, that's not the case I'm talking about. Go away, you belong to the ceteris paribus clauses. So it looks that, I'm not saying this is the truth, I'm just saying that if you look with Popperian eyes, with these falsificationist eyes to the problem, then you may say, look, that doesn't really fit. The practice isn't really Popperian. This is somehow different. The reaction of economists to the missing adequacy of falsificationism to economics. There are several possibilities, and they were really taken by economists. Some people took it seriously, and they said a critique of economics and a plea to do better, mostly by methodologists. Namely, they said, we got to revolutionize or develop economics into the direction that we need more severe empirical testing. So they decided on this tension between the normative philosophy of science and the practice of economics. They said the normative philosophy of science is right, and we've got to change the practice of economics. Right? Insofar, this is a proper critique of our practice, and we should change it. This is one camp, methodologist. A critique of falsificationism is another possibility, namely as not being adequate to economics. Economics is unable to comply with the requirements of falsifiability and severe testing. According to falsificationism, economics would then count as a pseudoscience. And then these economists say, well, that only shows that these standards are just not suitable. They may be suitable to physics, perhaps they're not even there, but they're not suitable to physics, so we don't really care about that. And we say, no, economics is a different kind of enterprise. We try much more to confirm hypotheses, and this is our practice, and therefore this doesn't really hit us. Or, of course, indifference. How most scientists react to philosophy. Let them talk. They say, yes, fine, yeah, you got a position as a philosopher, but I'm not interested in you. But as far as the discussion is concerned, these were the ways. And here you see that statistically, so to speak, it's open who is right. I mean, are the falsificationists right that economics should have stronger testing of empirical hypotheses? Or is it so that these standards, that they perhaps fit physics, and even if they fit physics, they don't fit economics, and economics is just different, and then these people would say, let's develop independently of these philosophers. They are useless. They can't tell us anything that's useful for us. It's very important to see that the original Popperian position is very, very radical, right? And watered-down versions of falsificationism, they abound in economics and in many, many, many other disciplines. Namely, saying things like, yes, of course, hypotheses, models, and theories have to be empirically tested. You will hardly find anyone anywhere in science who denies that. People may say, yes, we need some time, autonomous development of these hypotheses, not immediately killing them by empirical tests. But in the long run, of course, it has to be. So there's almost nobody who disagrees with that. But that's not the essence of falsificationism, right? That's much more radical. And these watered down, yes, there people do agree. The central thesis, as I said, falsificationism are much stronger. Testing, which is the main activity of science, means attempts to falsify, not to confirm. The only possible form of confirmation is the survival of critical tests. So every empirical test in science, according to falsificationism, must be critical, trying to falsify, and nothing else. And this is a very important thing that I've seen. This is now, it's a little out of fashion. The willingness to determine in advance what would need to happen such that the hypothesis would be given up, a typical question by Poparians. So I've seen that really in talks. So there was a Poparian talking about something, whatever it was, a scientific issue or whatever, and then someone in the question and answer period said, would you specify the conditions under which you would give up your hypothesis? Specify that in advance. Right? This is what the Poparians ask for. You've got to specify under which conditions you give up. Right? Meaning that you cut that all your ways out of the problems, that you block yourself. And if you don't do that, then you're not a scientist, according to Poparianism. It's very radical. It's very, very radical. And certainly, I mean, usually scientists would never say so, and even if physicists wouldn't specify that, because they say, well, let's see what sort of empirical data we get, and then we talk about it. I can't tell you in advance what I'm going to do then. I have no idea. It just depends on the case, right? Whereas the Poparians would say, if you do not give me these answers, then you are not willing to specify the falsifiability conditions of your hypotheses. So probably most people, scientists, would say this is an exaggerated position, and it's not tenable as a normative philosophy of science. But anyway, this is the position. It's very radical, and therefore scientists say, well, that doesn't really fit. We don't use that. Okay, so this is the Poparian position, and be careful when people tell you in economics or wherever that well, I'm a Poparian, then you really got to ask what this person means. If the person simply means, yes, in the end, everything has to be tested empirically, fine, but that's not Poparianism. It's much, much more radical.